All right, so today we are going to be talking about 2.4, which is the cosine law. So if you recall from, excuse me, last semester, the cosine law is given as a side squared equals the opposite sides, the square of the opposite sides added together minus 2ab cos c. In that, you'll recognize this c squared equals a squared plus b squared. That's basically the Pythagoras theorem. And then we've got this additional calculation here, which can help us either to determine a side length or an angle. Okay, so if we look at the first question, a surveyor needs to find the length of a swampy area. She measures the distance to one end of the swamp and the distance to the other end of the swamp, and the angle of sight between the two as 78.6 degrees, and we want to determine the length of the swampy area. So what we do is, of course, we draw or sketch a little diagram, and from that diagram then we can just start using the cosine law to determine the distance that we're looking for. So first thing that we want to do is look at our cosine law, and we're solving for side A. So we're going to take b squared plus c squared minus 2 multiplied by b multiplied by c, and then cos of A. And from there, we would get the square root of a squared equals square root of 570,715. Calculate that distance by taking the square root of that, and we end up with 755 as our length. Okay, so once again, fairly easy, pretty straightforward. In our second example, we have a bridge strengthened by triangular braces, and one brace has a side length of 14 meters, 19 meters, and 12.2 meters. Determine the measure of the angle opposite the 14 meter side to the nearest degree. So what we want to do in this situation is draw our triangle, okay, given the side lengths. And this time we're going to use this sine law, but we're going to rearrange it because we're solving for an angle, okay? So from there, we can rearrange it in this fashion, okay? So we move the 2ab cos c over to one side, bring the c squared over to this side by subtracting it, and then we're going to divide by negative 2ab. Substituting our values in, we get cos of c equals 19 squared plus 12.2 squared minus 14 squared all over 2 multiplied by 19 multiplied by 12. Then we're going to take the inverse of that value. Okay, so you put this whole thing into your calculator, okay, and we take the inverse of that, and we end up with c equaling 47.393. So the given angle is approximately 47 degrees. Okay, and in our last scenario, we're given a triangle, so we have to sketch that and determine the length of the unknown side and the measure of the angles. So our sketch should... Okay, so the first thing we want to do is we want to sketch our triangle. So our triangle would look something like this, and then we're going to try and find the side length. Okay, so we substitute our values in, and we end up with, sorry, skipped a step there, 11 squared plus 5 squared minus 2 times 11 times 5 cos of 20. C squared equals 42.63. Take the square root of that, and we find that C equals 6.529. Okay, then we need to figure out what our what another angle is. So we'll solve for angle A, and to do that, we're going to rearrange the equation to be cos of A equals b squared plus c squared minus a squared over 2bc. And then we're just going to start substituting our values in. So it would look like that, 5 squared plus 6.529 squared minus 11 squared over 2 multiplied by 5 multiplied by 6.529. punch that into our calculator, and we're going to have to take the inverse of that to get the angle A. So angle A would be equal to approximately 816 degrees. Then to get angle B, we would have to take 180 minus 144 minus 20. So it'd be 80 minus 64, which would equal 16. Okay, and I didn't show that step here. I forgot to put that step in. So that would be how we would solve that problem, and that's all of the information for 2.4. It should be a review from last semester, like I said.